Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic, that is a bipartite graph and complete bipartite graph, guys. Okay, so the concept of this bipartite graph is really easy, guys. Okay, so a graph is called as a bipartite if the vertices can be divided into two different sets such that each and every set of elements will not combine among themselves. So basically there will be no edges in between themselves. They will have from one set to another set. So that is nothing but a bipartite graph, guys. Okay, so any graph could be divided into bipartite graph. Okay, so I'll be saying you some tricks, guys, so don't worry, you'll be getting more idea like how you can say it is a bipartite graph. So any graph vertices, if they can be divided into two disjoint sets, you can say clearly two sets such that each and every vertex is from one set to another set. So basically from here to here every connection should be there should be no internal connections. So that is the only concept. So that is nothing but a bipartite graph. Okay, so what is a complete bipartite graph? So complete bipartite graph is nothing but here if you observe there are some combinations missing, right? So from here to here there is no arrow, from here to here there is no arrow, right? Yes, so if you match every possible combination, that is a complete bipartite graph. It is same like complete graph, all vertices should map. So in the same way here all vertices from here to map to here, that is nothing but complete bipartite graph. So it is represented as a k m comma n, guys. So m indicates the number of elements in set 1 and n indicates the number of elements in set 2. So in this example, here in set 1 we are having 3 vertices, in set 2 we are having 2 vertices. So it is a K32 complete bipartite graph. So how many edges are there, guys? So how many vertices are in it? 3. How many vertices are here? 2. 3 into 2 is 6 edges. Got it? Yes. So this is the concept of a bipartite graph and complete bipartite graph, guys. Okay, so now first of all, if a particular graph is given, okay, so I'll be drawing some random graph, guys. Okay, I'm not targeting to make it into bipartite. Okay, yes. So how you can check whether this particular graph is a bipartite graph or not? So the first step is okay, so the first step what I will be doing is, I don't know whether it is written in any book or not, but I understood this as per my observations. Okay, yes. So first of all, start coloring the graph, guys. We will be having a separate dedicated lecture for coloring of graphs or graph coloring, but anyway I want to discuss it now itself like some basic. Okay, yes. So what exactly do they mean by graph coloring is that for each and every vertex they give one color, guys. So if I give yellow here, I should not give yellow here, here or here. So that is nothing but a graph coloring, guys. So for each and every vertex you will give one color, and you should not give same colors for adjacent vertices. So that is the only game here. Okay, yes. So assume that this is one vertex, one vertex, one vertex, one vertex, one vertex. So here I started with the 2 colors. So basically if it is a bipartite graph with the 2 colors, you should completely color the whole graph, guys. So I colored yellow here. I should not cover yellow here, right? Because they are adjacent points. So the point is 2 adjacent nodes or adjacent vertices should not have same color. Okay, but here again they are there. Okay, so this graph is not a complete bipartite graph, guys. So if you observe for our original example, I will color yellow here. So I will color blue here. I will color yellow here. I will color blue here. So alternately I can color just with 2 colors. So if you are able to color a particular graph, so if you want a graph like that, let me draw it. Okay, yes. So I will color blue here. I have only option to color yellow here. I will color blue here. That's it. So this is a bipartite graph. So if you want me to draw set, this is one set, this is one set. In that way. Got it? Yes. So just by using the concept of graph coloring, we are able to solve it, guys. If you are having any confusion about graph coloring, we'll be discussing about that in the next upcoming lectures, guys. So don't worry or don't get anything. Okay, yes. Okay, so in examination there is one more popular question, that is the number of possible maximum edges in which pair you are going to have, they will ask, guys. So the concept here is quite simple. So they will say the maximum possible edges if a number of vertices given. So basically they are saying 12 vertices are there and you can make into any number of sets. So what are all the possible, guys? So we are going to divide into 2 sets. So assume that in set 1 I'll keep 1, rest 11 here. In set 2, 10. So in total it should read to 12 only, right? Yes. 3 means 9, 4 means 8, 7, sorry, my bad, 5 means 7, 6 means 6. Okay, so these are all the possible things, right? Yes. So if you recall, in when I'm discussing about a complete bipetite graph, I told you, so whenever you want to find the number of edges, you need to just multiply. So here the result is 11, here the result is a 20, here the result is 18, here the result is a 20, sorry, 9 3 sir is 27, right? Yes. Okay, so here the result is a 32, here the result is a 35, here the result is 36. So where there is maximum, guys, so at K66 you can find the maximum number of edges. Got it? Yes. So it's a quite simple topic, but it's an interesting topic, and the examiner always tries to give a question from here, guys. It might be theoretical or problematic. Okay, this is the PYQP, to be clear. Okay, yes. So now I hope everyone got a clear idea about bipetite graph and complete bipetite graph, right? Yes. So in the next lecture, let us discuss about cyclic graph, wheel graph and regular graph. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.